Wait for it. I'm watching. I'm watching the clock. Wait for it. I'm watching. Always takes longer this way. There we go. It is 2 hours UTC, and this is Astronomy Daily Live. So, hey, everybody, come on in, come on into the circle of friends who meet, get together each and every day to sit around on our comfy virtual lounge chairs out on the porch, you know, maybe under the sky, and just think and talk all things astronomical for a little while. It usually goes at least an hour, sometimes a little bit more, once in a while a little bit less. So it sort of depends on how things are going. Each and every day is a little bit different. So Bobby is in the chat. Um, Ata is also there. Hey, hey. Hope everybody's doing well. Hope your past 23 hours was well. Mine was okay. Just sort of a normal day. Now, I want to say this at the beginning. So tomorrow's live stream is not happening. Tomorrow's live stream. See this. It is 2 hours UTC on the 31st of May 2018. Right now, it's actually 20 or it's actually almost 2:02 UTC. Uh, so at 2 hours UTC on the 1st of June, which is tomorrow, there will not be a live stream. Not be a live stream. I'm doing a musical gig, and that's going to take me away from this location at that time. So instead of, as I said, instead of trying to hurry and get here and rush and stuff, it's just a heck of a lot easier just to say ain't doing it, ain't doing it. Going to just have some fun making some nice music tomorrow. So yeah, that'll be fun. Cheers. So hope everybody's doing well. Astronomy Daily Live is just a casual, fun get together of friends where we share a passion and we talk about all things astronomical and uh, you know intertwined with that is sort of a scientific bent, I guess is the right term, right? I mean, I'm extremely curious about practically everything, but I'm also extremely skeptical, and I'm extremely open-minded. So when um, I'm presented with any kind of information at all, I'm gonna look at it and go like, huh, really? Okay, got to look at this a little harder, and so I will. I'll look at things, but I will definitely not close my mind off to things, and belittle or really in any way um, um, you know um, degrade um, anybody's ideas, right? Because crazy ideas are what we now think are true, and so I'm totally in favor of crazy ideas. Um, and I don't care if they aren't popular. I just don't care, right? Um, I think it's all extremely interesting, all extremely useful, and if somebody wants to have an idea about um, a particular thing, it's like, well, go for it, right? Don't knock them down. um, you know, um, allow them, to do their thing. And if you don't agree, or you don't like the conclusions or anything else, just don't pay any attention, right? You don't have to knock them down. There's no reason to, right? I mean, that'll happen if what they're saying and um, what they're thinking in terms of some kind of scientific concept, that'll come out in the wash, right? So you don't even have to worry about that. So cheers. So I noticed that there was an interesting article on Archive, I think, or today, and I posted it up on on my Discord server just a little while ago. It was about the Cubesat spectrometers. Did you see those? I'm gonna share my screen here, and pretty cool. Pretty cool. Let me pull up my Discord here. I'm totally unprepared. It was interesting and sort of cool to see Skylius on the weekly space hangout. I thought that was moderately moderately interesting. What was I going to go for over on my smartphone? Oh, no, I was over here. For some reason, I switched to my smartphone. I guess I can watch the live thing from my smartphone here. It's a great way to monitor, make sure that it's still going. So okay, yeah. Uh, but yeah, I think this is pretty cool. I guess this of hasn't been done before, which surprises me. Um, see if I can pull it up here in a reasonable amount of time. Paper about a uh, a recent uh, of 800 and some trans-Neptunian objects, which I thought was pretty awesome. The more we look, now look, I guarantee this, right? I'm not sure about most things, but I'm pretty sure about this, and that is the more we look, the more we're going to find, and there's never going to be an end to it. So sit back, enjoy, and watch the discoveries roll in, because there's just we barely on discoveries. So anyway, yeah. So low cost space based astronomical spectroscopy. So it says that CubeSats are used for photometry, which is measuring the brightnesses of things in space. But spaceborne spectroscopy, however, is still the exclusive domain of much larger platforms. And so, as I said, that's what I was surprised at, was the fact that this wasn't already being done. And of course, right now this isn't being done. Right, this is a proposed, um, very small, but they'll have sort of two different modes: low resolution and high resolution. It looks like they'll be looking in the wavelengths. They use reaction wheels to move the thing around and to track. Um, and so, you know, I really, the only real question that I have is why been done before? What's the what was the hurdle to making this happen? And honestly, I mean, I would have to read the paper pretty carefully to either get that answer directly or sort of infer it, right, from what was uh, written here. But it's pretty awesome though, pretty awesome. Um, and I mean, most of this paper is just sort of an outline of what spectroscopy can do, right? Which I mean, if you're into those kinds of things, it's like yeah, we already know this, right? Um, but they had some pretty awesome looking pictures, right? I always like pictures. So this fits apparently into uh, a 6U Cubesat. So there are the wheels, and then everything else is electronics down here. Here's the spectrometer itself, right? And then here is the telescope up here. So pretty cool. Pretty cool. And their radios and all that. There's a spectrometer. Using some pretty serious CCDs, right? A 1K by 1K, space qualified. So the rectangular aperture of the primary is 92 by 192 millimeters. So yeah, I mean this CubeSat, it looks like man, it looks like it's 20 20 by uh, 30 centimeters, right? So it's it's the it's smaller. Well, yeah, 20 by 30 by 10. So it's much smaller than like an airplane carry-on bag, right? But it's 92 inches wide and 192 inches long. Um, Focal length is 160 millimeters. So then, yeah, you've got the spectrograph, you've got um, this high resolution one, which is called a shell spectrum, ECHELLE. And then they just use a prism for the low resolution one. That's very cool. Let's see. This is just sensitivity per wavelength. So yeah, 10 to the third, 10 to the fourth. That's a pretty good signal to noise ratio. It's it looks like they're only going to be able to look at bright stars, but there's a lot of bright stars. There's a ton of bright stars. But yeah, anything anything fainter than about 12, they're just not really going to be able to see very well. So that's not bad. That's not bad. Here's the uh, reaction control system. It's in half of a U. That's pretty cool. So what, 10, 10 by 10 by 5 with some standoffs here of some sort. That's pretty cool. Overview of the Cubesat pointing control. So it's going to be looking at a star, right? Some kind of a reference star out this hole, right? Out this hole here. There's some kind of optics that has a camera, and so they're going to lock onto a star and then close the loop. Picture of a prototype beam splitting mirror, two amplified piezo actuators, measured frequency response of the beam steering mirror. Okay. Got some interesting resonances here. Way out there, though. This is also logarithmic, so this is, 2 times 10 to the second, or 200, 300, 400, 500. So this goes to 500. This goes to 500 hertz. It's pretty close to middle C on the keyboard, by the way. So project status and planning. The Cubesat mission and payload concept has so far been studied from internal sources at this place. We're currently in the process of planning and proposing a technology development project with the European Space Agency, aiming at a phase A study in 1 year and phase B, C, and D extending over 2 years. There we aim at an in-orbit demonstration on a timescale of 3 years. The long-term goal of this project is to provide a generic, low-cost, recurrent, off-the-shelf solution to deliver spectroscopic monitoring of point sources from space. Customers' requirements on spectral resolution and spectral coverage shall require only minimal hardware changes. Yeah, I think it's great. See, I mean, put 1,000 of these up there, and you practically eliminate, right? You practically eliminate the need for ground-based observations. It's great. It's great. We should do this for sure. I like it. I like it a lot. I want at least 10 Hubble Space Telescopes up there. I mean, the Hubble Space Telescope is oversubscribed by, I've heard, at least by over a factor of 1,000, right? So for every 1,000 proposals that they get, they accept one, and uh, I mean, it's that Hubble Space Telescope is constantly going, right? There's no downtime at all. It's constantly going. I mean, I'm sure there's some kind of a schedule, but I mean, it's going and going and going and going and going, and oversubscribed. So you know, why don't you put up 10 of them or 100 of them, um, and relieve some of the pressure right down here, because everybody wants um, um, data without this atmosphere, right? I mean, it's so sad, right? It's so sad that this light, right? That this light from star, galaxy, whatever, right, has been traveling for you know years, hundreds of years, thousands of years, millions of years, right? Just going along, going along, going along, right? And in the last few nanoseconds, right? In the last few nanoseconds, it goes from this really, really nice, you know, basically flat wavefront to passing through our atmosphere and being completely distorted, right? Almost to a point where it's like, you know, why bother, right? Almost. Um, so you know, it's pretty sad, right, that that this light's been traveling for millions of years, and then the last nanosecond it gets screwed up, right? So you know, if you can have a telescope above the atmosphere, then you don't have to worry about that, right? And HST has been very successful, right? Very successful. I don't know why you couldn't build, and I'm just, you know, throwing ideas out here, but I mean, why couldn't a business model be developed for that kind of thing? And you know, have a number of these space-based observatories out there that, I mean, astronomers have to pay for it anyway. So you know, uh, but have, you know, like 100 of these HSTs out there to relieve a little bit of the pressure, right? Um, Maybe we can use, you know, these ground-based observatories for something else, something else. You know, I mean, there's always something else. So anyway, yeah, I think this CubeSat spectrometer is a great idea. And as I said, really my only question is it's like, why has it taken so long to do that? Because I mean, it seems it's just, you know, I mean, I don't know. I don't know. There was, I guess there was some kind of technology missing, um, maybe in terms of the control system. Because I mean, small optics and stuff, I mean, that's easy. I mean, that's super easy. So I don't know what the difficulty is. Maybe it's the power source. I guess we didn't look and see how it was powered. Um, can I look really quick? I'm gonna look without showing you, so you get to watch me um, search for how these things are powered, how this thing is going to be powered. That's talking about spectroscopy. I mean, I assume it's some kind of solar thing, but let me just do a search for power, resolving power, battery pack, and power management. Okay, the it says the electrical power system is sized to allow continuation of measurements even in eclipse. The solar panels are not included in the image for clarity. Okay, so this is going to be using solar panels um, and batteries. Okay, very cool, very cool, awesome, awesome, awesome. Yeah, and I would think that something like this is relatively inexpensive. That's why I say throw 100 of them up there or 1,000 of them up there, so you know we astronomers can actually get some work done, you know, and get some data that isn't messed up by the atmosphere. It's brilliant. It's brilliant, and I mean it's a small mirror, right? I've got a book here. I'm gonna Well, what, it's 19.2. I've got a ruler too. Let's see. So 19.2 is is to my finger there, right? So you can sort of get the scale, right? It's a little smaller than my head. That's how wide it is. And then it's 92 inches high, or millimeters high, which is 9.2 centimeters. So it's that, right? So I mean, it's not a huge. Let's see, this book is 17. This book is 17 by 10, right? So the mirror on this spectroscope is a little bit wider than this book, and this is just a paperback book, right? This is a paperback book size book. So this is 17 wide, or 170 millimeters wide, and 100 millimeters high. So it's about that size of a mirror, and that's pretty decent. That's a pretty decent size mirror, um, especially if you're going to put it into space where your sky is really black. It's really dark up there, um, and the stars don't twinkle, right? So awesome, very awesome. It's about that big. Cool. All right. Well, cheers to Cubesat. Unfortunately, we're going to have to wait a few years to actually see this thing go, but this is definitely something that I want to follow because yeah, I mean, I'm somebody who might be interested in using that kind of thing. If the price is right, um, or if the data, and even better, right? If that data um, is made available, maybe not like immediately, but at some point, then it's like I just have to wait, right? And I am very patient. I'm very patient. Cheers. So yeah, I started talking about Skylius on the weekly space hangout, and yeah, I don't know if anybody else picked up on this, but the vibe was really different. The vibe was really different today, and not quite sure what that was, but everybody was acting a little strange, a little strange. So that's cool. That's cool. And Skylius, I mean, she deserves. I mean, it's I mean, I can only imagine, right? I can only imagine doing what she's been doing for what I think she said like 3 years now. Um, that's pretty intense, pretty intense, and she knows her stuff too, right? And she's also able and willing, to put up with a lot of crap too. So hats off to her for sure. She's this is at least the second time, maybe the third time that I've heard her mention burnout, and that sort of concerns me a little bit because she's really awesome, and she's put a lot into this. Um, but if she's feeling burnout, she needs to do something about that, like really quick. Otherwise, I'm afraid one day she's going to wake up and say, "Screw this! I'm not doing it anymore. I'm tired of it." Right. So what I found in my old age is that you uh, do things that are fun, and then it's not work, it's not a burnout, it's not anything at all. It's just something that you do, um, and that's what this live stream is all about. I mean, as I said, part of the story with me deciding to do this live stream is that literally for years and years and years, right? I will sit here in what are my evenings, and I've been working all day. I usually start my days early, and pretty much from the time I get up um, until I go to bed, I'm working on something, right? Um, uh, some of it's physical, but a lot of it is thinking and writing code and trying to figure things out and reading and all of that. And so, I mean, for years, every evening I would be here, right? Literally right here, um, looking at astronomical things, reading papers, um, you know, writing code, looking at data, um, learning things, whatever, right? And it's it finally dawned on me. It's like, well, why don't I just live stream this and that'll sort of keep me on my toes a little bit, because see, that's one of the cool things, right? Is that the the only one that's obligated in any way to be here is this guy right here. And really, honestly, folks, I'm only doing this because I want to, not because I feel as though I have to, or that I'm going to get anything out of it or anything else. I'm doing this because I thoroughly enjoy this. Um, uh, as I said, I'm not a science communicator. I'm not a educator, but watching this live stream and participating in this live stream, communication will take place, and hopefully we will all gain an education. But I definitely want this to be a little bit more than that, because that's sort of like a lecture, right? Where it's like, okay, children, I am the high priest. I have the answers. So you ask me questions, and I will give you the answers, and you will just be, in total awe of my knowledge and cleverness to be able to explain things in simple ways so you can all understand. And I'm saying that in a sarcastic way because I don't agree with it at all. I mean, absolutely, absolutely, everybody is at a different level in terms of understanding, in terms of intelligence. But so, I mean, that's what makes things interesting. I appreciate that, right? So I mean, uh, uh, take what you can out of this live stream, and my approach is that I actually like concepts to sort of be over my head, right? I mean, if they're hitting me anywhere else, it's sort of like, well, I'm already aware of that. I'm whatever, right? Um, but these these concepts and these new things, if they're over my head, and then I have to reach for them a little bit, right? I have to get a little better. I have to know a little bit more. I have to figure out how I'm going to figure that out. Um, Now there comes a point, right, where if the concept is like out of reach, right? I mean, I'll stretch up, right? And if the concept is way out there, right, that I'm not able to touch at all, then I'm probably not going to get a lot out of it. But if I can reach up and grab it, even if it's just like just a finger or so, it's like, well, cool, cool. At least I can grasp a little bit of that, right? So that's very, very cool, and that's sort of where I'm coming from with all of this. This is just fun, um, uh, and if you get something out of it, that's great. That is really, really great. So speaking of getting something out of it, um, yeah, exactly. um, Atta. If you don't stretch, you don't grow. And that's absolutely true. It's absolutely true. Speaking of stretching, usually right after this live stream, man, the first thing I do is I get up and I stretch, because it's just, um, I mean, I thoroughly enjoy sitting here and I'm bouncing things around with all of you. But after an hour, I definitely need to get up and move around a little bit. So yeah, yeah, I'm just getting old. That's all. I'm just beginning to break down. That's all. It's part of the machinery. Whatever. Someday, someday soon, I'm really hoping that we're going to be able to just replace various parts. I don't see any reason why we can't. Um, so you minimize the breakdown. That's what dying is. Um, is just damage, right? Is damage done, and if you can either minimize that damage or reverse it in some way, aging will not occur. It just won't. Um, so yeah. In the meantime, hydrogen hydroxide, lots of it. Cheers. All right, let's do a constellation of the day. Now, there are, at least according to the International Astronomical Union, okay, there are 88 constellations. And I'm going to go to my list. I have a alphabetical list of all 88 constellations now loaded on my Linux machine, which by the way, I have yet to update. I actually updated my other Linux machine to Fedora 26. I'm going to be doing exactly the same thing on this machine soon. I wanted to. I'm such a chicken, right? But I wanted to see what happened on on a machine that is not necessarily used a lot. I should use that other machine a lot more because it's much more powerful, but I just haven't yet. So anyway, that installation went. I mean, almost unnoticed. It rebooted a couple times, and that's it, right? So yeah, I need to do exactly the same thing. Anyway, so I've got the 88 constellations up on my screen, and as Tom pointed out, and I don't know if Tom is in the chat or not. Uh, well, yeah, but I think the telomere count is a um, I mean, I guess you could sort of define that as damage, right? Because things are falling off, or that count goes down, right? So something is happening to damage that process. So yeah, the interesting thing, right? I mean, um, about cancer cells is that, as far as we know, they are immortal. They live forever. I mean, as long as they have a host, right? That's sort of the problem, though, is that the host vanishes after a while. But at least what I've heard, the characteristics of a cancer cell is that they do live forever, and I think research. I mean, if you're interested in living longer, which as I age, I guess I'm getting less and less interested in that. Go figure. Um, uh, but if you're interested in such things, I would think that there would be a lot of interesting research things to do there, and maybe there are. So I don't know. All right, constellation of the day. Let's. I'm going to share my screen. I keep forgetting to do. I thought I did it before and I didn't. Okay, there we go. I'm going to hide that. Gone to infinity, which is always fun. You can see the mouse moving around there to infinity. Yeah. All right. So let's go over to random.org. And we will have this website choose for us an integer between 1 and 88. Oh, and as I said, Tom pointed out, I think the last time I did a constellation of the day, that there are about 1.5 times as many southern constellations as there are northern constellations. And, I mean, the only explanation for that, of course, is that the constellations in the south are a little bit smaller, right? So because you have equal area, so the only way that you can have more of them is if the areas of the constellations are smaller, right? Um, so yeah, there is a more likely chance that we will hit a southern constellation than a northern constellation. However, I think I've done 5 or 6 of these now, and I believe only one of them, Hydra or Lynx, I think Lynx, um, uh, was the only northern constellation that we've done so far. Everything else has been like really, really, really south. So like invisibly south from the northern hemisphere. So good on you all, who are in the south, but I don't know. It just doesn't seem very fair. But as I said, there is a higher chance of getting a southern constellation than there is a northern. But let's see what one we get today. And then what I like to do is I like to go into the constellation. We'll look at it. We'll see where it is in the sky. We'll sort of look at the pattern of stars, and then we'll start to see if there's anything interesting, right? That catches either my eyes or your eyes, that we can dive a little deeper into. If there's some kind of interesting object, maybe we can go over and grab images from the Hubble, and make a picture out of it. Whatever, we'll sort of see where this goes. I like to, as much as I possibly can, I like to just follow my nose. I don't really have any kind of plan here. So, all right, let's see which one it is. Drum roll, please. Number 45. Okay, I'm going to look at my list here, and I'm going to go to number 45. It's an alphabetical list, and so the 45th one on my list is the constellation Lacerta. So let's go over here. Usually Wikipedia has a pretty good sort of entry point. Lacerta constellation. It is a northern constellation, as I thought it was. So its name is Latin for lizard. It's a small, faint constellation. Okay, well let's take a look at it here. See what we're dealing with in terms of where it is and how big it is and all of that. So okay, so it's between Andromeda and Cygnus to the west and east, and just north of Pegasus. Okay, south of Cepheus. All right, yeah, so it's just a little constellation here, fairly dim stars. Um, you can sort of see there's a magnitude scale here on the bottom. So the smallest dots on here are sixth magnitude, and the biggest dots are like first or brighter. And if you didn't know this, the magnitude scale, the brightness scale, um, um, with astronomy is sort of reversed. So the larger the number, the fainter the star. So a first magnitude star is 2.5 times brighter than a second magnitude star, and a second magnitude star is 2.5 times brighter than the third, on and on and on. They're factors of 2.5. It's a logarithmic scale, but it's reversed, right? So Vega is sort of defined more or less as being zeroth magnitude. And then based on that, Jupiter is around what, almost -2 right now, at least. Venus is like -4. The moon is about -12. The sun, I think, is about -26. And then the faintest that sort of normal eyes can see on a really dark site is about sixth magnitude or so. And that's why everything down to sixth magnitude is shown here, because these are the visible stars. So stars usually have many different names. Um, Stars that are pretty visible in the constellations are have at least one name based on their brightness. So usually the brightest star in the constellation is called Alpha, so Alpha Lacerta, and then the next brightest one would be Beta, and if there was a third one, Gamma and Delta, then on and on and on and on and on. Stars also have other names, which can be numbers as well, and they're usually numbered according to right ascension. So going from west to east, so from a lower right ascension to a higher one. I'm gonna pull my chat up here again. Hey there, Patrick. Nice to see you. Yes. Patrick is a Windows insider. Very cool. So yeah, this is a pretty small constellation. As you can see, it just goes about one hour of right ascension over, and then several degrees here, at least 20 degrees of declination or so. So yeah, I mean it's a smallish constellation. Looks like it has a what I would call an open cluster here. NGC 7243. Looks like there's some other things here. I guess I'm not too familiar with. There's some red dots here. I don't know what those are. There's this green dot, which is probably like a planetary nebula. And there's a square green, or a green square, that's probably also some kind of nebula, maybe a diffuse nebula. Here's a green square around a star. That usually designates some kind of nebulosity around that star. But so let's go back and look and see what Wikipedia um, uh, says about this constellation here, the constellation of Lacerta, the lizard. Notable features: stars. Um, so no bright galaxies, no globular clusters, but instead has open clusters. Um, a planetary nebula, some double stars. Oh, and the famous BL Lacerta. Yeah, that's a pretty interesting object. Let's see. So Alpha Lacerta is just a main sequence star. It's a spectral type A, so that's pretty blue. That's a lot. That's a lot bluer, probably a lot brighter than our sun. Our sun is like a G2 star, and this is an A1. So, uh, yeah, the order of spectral types goes O, B, A, F, G, K, and M, and then there are ones below that, below M stars, and there are also stars above O stars too. Um, but yeah, so this is an A star. Our sun is a G star, and then Beta Lacerta is a yellow giant. Oh, that's very cool. Okay. So there's a multiple star system here. Wow, there's like 5 stars. I would almost call that a cluster, right? Row 47. Um, Binary star around which a planet orbits with some unusual properties. Okay. Um, Unexpectedly low density. Okay. Well, that's quite an extrapolation from just being able to measure the brightness of this thing. But yeah, our models can tell us things whether they're true or not. Well, we'll find out. So EV Lacertae is a rapidly spinning red dwarf with a strong magnetic field, and apparently it flares. Um, with those flares possibly being visible to the naked eye. That's pretty cool. So 7243 is an open cluster. Um, BL Lacertae. I think I'm gonna pass on BL Lacertae. I'm sort of I'm sort of leaning either towards row 47 or NGC 7243. Does anybody have a preference either way? Thank you, Uncle Bill. You are the man. I can say that I'm sort of leaning towards row 47, but I don't know how much information there's going to be about that. I don't know. What do you think? The other thing that I can do is while you're thinking about this, I'm going to go to Burnham's Celestial Handbook and see if there's anything interesting about Lacerta. Ah, there is. Wow, lots of binary stars. So there was a nova in 1936, made at the 13-inch telescope at Lowell Observatory. Was a nova that took place, well, let's see. Yeah, the actual nova of the star itself, I guess, was called CP Lacertae. And Yeah, kind of cool. Well-observed nova, which was first noticed on June 18th, 1936. 1.5 arc seconds south of arc seconds. Wow, south of Epsilon Cephi. Sorry, 1.5 degrees. The exploding star reached its maximum magnitude of 2.2 on June 2nd. Um, yeah, and that was a rapid rise, very rapid rise. So that's pretty cool. Um, I wonder if let's just well, let's plug into CP Lacerta and see if there's anything interesting about that over on Simbad. If not, maybe we'll look at row 47 really quick. But let's look at Simbad here and let's just see. I guess I'm more inclined to look at a cluster than just an individual star. But let's see if there's anything interesting about CP Lacerta. CP Lacerta. So it is being classified as a nova, is a new star. You can see the coordinates of it here, right? Right ascension, declination. So right ascension of 22 hours, 15 minutes, 41 seconds. Declination of positive 55 degrees, 37 minutes, 1.4 seconds. Doesn't have any measurable velocity either towards us or um, away from us. Very faint, very, very faint. You need a big scope to see that bad boy, right? At least right now. Maybe it'll go nova again. Who knows? I think the Discord is invalid. Uncle Bill, try again. So there's the various names for it. Quite a few references, but all sort of old, right? In the past 20 years, it looks like there's only been 34 out of a total of 118. So hasn't been recently looked at. So this is talking about velocities. Maybe it's just all zero. Oh, okay. Yeah, it's just all zero. Okay. The galactic nova rate revisited. That's probably a useful piece of information then. All right. Yeah. Nothing too incredibly interesting here. Let's look at row 47. Just sort of see what that's all about. Oh, okay. So they have a link to a Wikipedia page, but they have no information about it. Okay. Well, let's take a chance here and go over to HST and see if row 47 comes up. You can look on Simbad too. We can look at all images, all spectra. Row 47 not found. So let's go over to Simbad and see if there's anything about row 47. Don't like to give up on things too easily. Now, wow. Does it have another name? There's not even there aren't even coordinates. There's nothing. Sources. Deep photographic guide to the constellations. Lacerta. Let's see. I don't like to give up on these kinds of things. That's not going to help. Big image with marked objects. Yeah, well, this is showing a much larger field of view too. So sort of is somewhere in here, right? Just this little thing. Yeah, wow, that's not helping at all. Wow, we're gonna hit a dead end on this one too. Not fair. Not fair. Well, let's look at NGC 7243 then. Excuse me. Too bad. We already know that this is an open cluster, which makes sense. You know, Lacerta is in the galactic plane, and there are that's where the open clusters tend to be is in the disk of the galaxy. What was it, 7243? Was that right? 7243. Yeah. 7243. Okay, let's take a look here. Open galactic cluster, right? Pretty bright. The this is not showing very much. Got a couple of different names. Usually these other names are just, different catalogs. For some reason, it's showing the references. Quite a few references, I guess. Um, I didn't want it to. I didn't want it to show all the references, but I guess since we're here, let's take a look. Global survey of star clusters in the Milky Way. So they're just looking at brightnesses and luminosity functions. Discovery of secular variations in the atmospheric abundances of magnetic AP stars. Wow, I don't know what that is. UCAC 4 catalog. Global survey of star clusters in the Milky Way. Number 2, the catalog of basic parameters. Can't be any simpler than that. Well, let's see if HST took up some shots of this thing. 7243. NGC 7243. What are the chances? Not good. Yeah, HST hasn't looked at it either. Wow. Just striking out. New catalog of blue stragglers in open clusters. This is from 2007. We present a catalog of blue straggler candidates in galactic open clusters based on the inspection of the color magnitude diagrams of the clusters. Yeah, well, that's a pretty simple way of doing it. You look at the color and look for the blue ones. How hard is that? Okay, yeah, Patrick, I think I've been thinking about this. I think I do need to fix that link. I that is definitely. I don't think that's the way uh, to come in. So my apologies there. I need to look at that. And thank you for the indirect reminder that I wanted to do that. Yeah, that's probably not a valid link anymore. But maybe it is. I don't know. I'm going to look at it. Maybe I completely misinterpreted what you just said there. So blah, 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 blah. Total of 1,887 blue straggler candidates have been found in 420 um, open clusters. So, this was written back in '07, right? So this is 11 years old. So I'll bet you some new stuff has come along too. Now, what was that? 7243. All right, let's see if 7243 is mentioned. 7243. There it is. So what is this table? Okay, so peculiar blue stragglers. See the notes of the catalog. So yeah, I don't know what an AP straggler is. That's the only place that it's mentioned, though. So let's see if wow, there's maybe A is the type of star because I'm seeing B and O. So let's see if we can find out if this paper says anything about what AP stands for. Nope. Try this. This is the desperate way. I'm going to find every single reference to AP. That's no good. Yeah, I'm not quite sure what an AP straggler is. Shall we see if we can figure that out? Can't believe it's already 3:08 UTC. Wow. So it's a type of blue straggler, but we knew that already. Yellow stragglers. Now that's not going to help, I don't think. See if AP is in here. Nope. Yeah. Thanks, Atta, for coming in again. Come on in any time you want. As I said, except for the rare occasions like tomorrow, I am always here. 2 hours UTC. You can feel free to come in any time you want. Don't feel as though you have to be here every day. If you want to check in um, every day, that's awesome. That's very awesome. But come in every other day, every week, every month, whatever your schedule and life um, sort of allows. I don't have any plans on going anywhere. So, and there's so much to talk about. I mean, I can spend lifetimes um, doing this. 12 hours a day, right? I mean, I only do it for about an hour. So yeah, there's so much to talk about. I'll never be able to talk about it all. So don't feel as though you're missing anything. And all these are saved on my YouTube channel, so you can always just watch these things um, later um, at your convenience, right? All right. Well, this isn't getting me anywhere. So uh, I'm zoomed in way too much here. Can't see much. So yeah, these guys are just looking for blue stars. That's how it's done, and they just describe their methods. And they're pointing out anything unusual or new, like these clusters um, uh, are listed as having blue stragglers for the first time. So up until now, they they didn't know that there were any blue stragglers in those clusters, and now they do. So that's pretty cool. Just useful information. If you're into these kinds of things, this kind of data is extremely important. And blue stragglers are one of those mysteries still. Nobody really knows what's going on with them at all. The current theory is that they are they're the result of merged stars. So two lower mass stars um, merged in some kind of very rapid event, and some of those masses sort of heated that star back up, and it changed color. Right, that's what temperature apparently shows. So did anybody update their Chrome browser today? Well, I didn't. I Is that something that is being recommended that we do? Um, so yeah, haven't heard about that, Bobby. Do tell. Smash the thumbs up if you like this. Um, Smash the thumbs down if you don't. As I said, I'm interested in reactions, and I'm interested in the absolute value of the reaction. So whether there's an up or a down doesn't I think that's great. I think that's great. So, but yeah, let me know what's going on with Chrome there. And I think while I'm waiting for that, I'm going to start getting out of here because yeah, I'm getting the message. So yeah, I think I'll get out of here for today. Yeah, I think it's time. I think it's time. So hope everybody has a great evening and a great day tomorrow. Um, and the next day, as I said, tomorrow's live stream is canceled. It's canceled. I'm not going to be here. I'm playing out at a musical event and with my musical partner. He plays native flute, and as I said, he's very 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 good, very good, and makes my job super super easy. So nice stuff, nice calming, um, um, you know, sounding things. And as I said, for me, he makes it easy. So that's where I'm going to be tomorrow night. But I will be back the next day. So June 2nd. Wow, it's June. It's June. June 2nd at 2 hours UTC. I will be back here, and we can gather again and think and talk some more astronomy and life in general. Whatever. I'm open to all kinds of things. Want to keep the focus, you know, uh, on the astronomical side, but some tangents are, I guess, acceptable. So, all right, cool. All right, I'm going to get out of here. Peace, cheers, and all that. And I will see you in 2 spins, 2 of them. 1, 2. Okay, peace out. See you June 2nd, 2 hours UTC. All right, take care. Bye.